Hello everybody. Today we're going to work on a Khan Academy style video for the Unit 1 of EOC review. First I'd like to start off with the vocabulary. Circle, the locus of all points in a plane, equidistant from a given point, called the center of a circle. Angle, the intersection of two non-collinear rays at a common endpoint. The rays are called sides, and the common endpoint is called the vertex. Perpendicular line, lines that meet to form right angles. Angles that are exactly 90 degrees. And that little asterisk is replacing the degree symbol, because as I couldn't find one on the keyboard. Parallel line is coplanar lines that do not intersect. They might have the same slope, but they will never intersect. In that case, they would have different y-intercepts and continue going on at the same rate and never actually meet. So these are called parallel lines, as you already probably know. Line segment are measurable parts of a line that consist of 2 points, called endpoints, and all points in between them. What will be covered in this presentation? In this presentation, we will discuss problems involving various subjects such as stretches, rotations, reflections, translations, and figure transformation on a plane, and how to solve each type of problem. As I already discussed, this is hopefully going to be very similar to a Khan Academy style video, which I personally enjoy, so I hope you enjoy and learn something. First off, I like to start with stretches. Stretches are pretty much just a form of transformation that you can do to a geometric object that makes an object either taller or wider using scale factors. One's called the dilation and one's called enlargement. Practice problem 1, this is the easier of the two. Next one will be a quote-unquote hard one, but we'll get to that in a minute. Stretch this triangle, I'm reading the prompt. Stretch this triangle by a factor of 3, which means it's going to get much bigger by a scale of 3. First off, we're going to find the distance between vertices A and B, as shown in the picture. And then we'll find the distance between A and C, the opposite side, vertex. And we'll end up using the area of triangle formula, which is 1/2 base times height. In this case, 1/2, 4 times 3 equals 6, which that's true because 4 times 3 is 12, and 12 times 1/2, or 0.5, is 6. And then, as the prompt said, we have to stretch this triangle by a factor of 3. So 6 times 3 is 18. Okay, this is the harder of the two problems, and I only say it's harder because we add another side. Ooh, tricky. Stretch the rectangle by a factor of 2. First off, we're going to use this distance between two of the corners, if you want to call them. Distance cannot be negative, so this is very important to know. Also, as a side note real quick, most of these problems, they're static problems, as I call them. They're static, as I've already, it's a picture. I cannot, as the normal Khan Academy videos are, I cannot currently write on the picture. So I'm just explaining what's going on and how to solve. Everything's there, but I'm just kind of walking everybody through it. I hope that's okay. To pick back up, for the step number 2, we're going to use the distance between B and C using the distance formula, and then we'll use the area of rectangle formula, which is base times height. In this case, the base is 5 and the height is 4, so that's 20, and a factor of 2, 40. So we're making everything bigger by 2. You're actually stretching it. You're making it longer, making it taller, but the same proportions. Rules for rotations. It's important to understand and memorize the chart below, as this might help you on any further test, and it's just good rule of thumb to know. Ms. K gave this out in a packet, and I hope you all still know where that is. So let's start out with the problem. Practice problem 1. The blue object has been rotated 90 degrees clockwise around point 12. Which is the correct image? I'll give you a minute to solve this one. Hopefully I gave you enough time. The correct answer, or at least what I got, is C, the brown object. Since we were starting from the blue L object, to rotate it 90 degrees clockwise is to take its A and B, X and Y, and put B first, but negate it, make it opposite or negative. However, it doesn't have to be, if it's already negative, you make it positive. You kind of give it the opposite charge, if you want to call it that. So, for this one at least, it's a little easy. But if you wanted to find out for yourselves, just plot a couple of the dots or points on the figure, and try this formulaic way that was shown in the formula box in the previous slide. Okay, we're going to try this medium, and in a medium question, and in hindsight, I should have, since I just found out that these were static images, so I cannot edit them in real time, I should have left this answer square, the square shown in the right corner, actually has the answer, but it's taken directly from Khan Academy, how they have sample problems and answers for you to do. But this question is showing a triangle PIN or triangle pin, and they want it to be rotated negative 270 degrees, which, wait, hold on, what is that? Negative 270 degrees? No, that's just saying 270 degrees counterclockwise around the origin. And under this square, it has the answer, which is just the same exact triangle, but with the new triangle, the prime triangle, in orange. And that's after the triangle has been rotated and transformed, as the problem said. Hindsight, I should have figured that out, but hopefully you understand. We're now going to move on to reflections. This is a pretty easier subject, and I hope this problem isn't too tricky to be considered medium. Which of the following transformations is illustrated by the graph at the right? A dilation, a reflection in the line y equals x, which is just a line with a slope of 1 that goes through the origin, 0, 0. A translation, that's a very generic term, I don't know why they said only translation, but it's asking what transformation, so let's keep that in mind. Or a reflection about the origin. I'll give you a second for that one. So hopefully that was enough time. What I got was the answer choice 2, or in my mind, B. And that is a reflection across the line of y equals x, slope of 1. And how to get that is you use rise over run. You go down 2. Let's pick this one. Let's call this point A. The point dot of the triangle located at negative 2, 1. Let's call that A. And from that, we're going to go down 1 and go over 2, as the line has a y-intercept of 0, which means it goes directly through the origin, 0, 0. So we're going to go down 1 from point A and over to the right 2. And we're going to do the exact same thing to find wherever A prime is. And that's down 1 again and over the right 2 more. So we end up with A prime, this new point, at 2, negative 1. And you continue to do the same tactic for each of the each of the dots shown on the triangle to get this new prime triangle. So we'll move on to translations. And this is just simply moving an object such as a triangle or a circle or a hexagon or a baseball or anything on a coordinate plane, you're moving it to the right or up or down or even to the left or even diagonally. It's crazy. Let's start with an easier problem. This in the question gives you the answer towards the end. But under the translation rule of x, y, x to the right 3, and y up 2, the point 2, 5 will become 5, 7. That's really more of a statement, but it's still a good idea to apply this this rule to the first point to get the second point, to see if you understand what's going on here. So this first point, 2, 5, let's call that A, a good letter, I think. This point A, 2, 5, goes under this translation of 3 to the right and 2 up. So from point A prime will end up being, under this translation, 5, 7. So it's like a new point of A. It's the new version of A. The second problem is a medium one, and I'll give you a minute here to figure out what's going on. So hopefully that was enough time for you to figure this one out. You should have gotten false. For example, let's take point A. No, sorry, H. Too much in the A mode here. Let's take point H. And it's currently located at the pre-image, which is H, G, E, F, not prime. H is located within the pre-image at 2, 1. And this translation says, hey, move it 6 units to the left, -6, and 3 down. Well, if you move H 6 units to the left and 3 down, you're more towards E, and it's not even close. If you count it out, it's not even close to this image. So hopefully that you got that, understood that. So figure transformation on a plane. I asked Ms. K this earlier in class today, and she said it's just, generically, it's the application of multiple transformations, such as a reflection and then a rotation and then a translation to one object. So you get multiple steps, if you want to call it that. Let's say we start with a triangle, and then the first prompt in the question says, hey, translate this triangle 3 units to the right and 1 unit down. And after that, you plot your points, and this is the prime triangle. And then it says, hey, reflect this new triangle that you just got over the y-axis. So this will give you the double prime triangle, the letter with the 2 little tick marks. And then the third prong, for example, would say, hey, in this last part of the question, go ahead and rotate it 270 degrees counterclockwise, for example. Then you just apply your knowledge of what we learned earlier for rotations, and you get this third triangle. So that's what figure transformation on a plane means. Let's go ahead and apply that to in quote-unquote easy problem. First of all, this prompt says to rotate the triangle 90 degrees counterclockwise around the origin, then reflects across the x-axis. You're going to go ahead and use what we learned from the chart. Change the points AB, x, y, to -v, -y, and then x. So you flop them and negate B. So A, which is located at 2, 4, will become A prime that's located at -4, 2. And B, which is located at 4, 2, will become B prime located at -2, -4. And finally C, which is located at 2, 1, will become C prime located at -1, 2. In the second part, we now have this first triangle, this first step. Hey, we've done this step, here's a triangle to prove it. We're going to take that triangle, and for the second prompt for the question, it says go ahead and rotate this 90 degrees counterclockwise. You're going to change the points from this new triangle AB, and you're only going to negate B. You're not going to flip them like you did last time. You're just going to negate B. So A prime, located at -4, 2, becomes A double prime, located at -4, -2. And B prime, which is located at -2, 4, becomes B double prime, located at -2, -4. And C, which is located at -1, 2, it then becomes -1, -2, C prime. And then you take that triangle, the third triangle that's now drawn on your plane, and reflect it on the coordinate plane against the x-axis. And for that, we also refer to the chart given. All you're going to do from there is take that last triangle you found, and you're going to flip it across the x-axis, which just means that you're going to negate B yet again. So it's kind of like we created one triangle, did another one, and then went right back to that other triangle, but that's just how this problem worked out. It was extra steps, but that's what the problem asked for. Let's go ahead and try this medium question. Figure transformation on a plane. Reflect across the y-axis, then rotate the figure 180 degrees counterclockwise around the origin. Okay, first of all, it's important to recognize or know that 180 degrees counterclockwise and 180 degrees clockwise are the exact same thing. So no matter which category you look at in the rotation chart in the packet, you're going to get the same answer. So if you already know the steps for 180 degrees clockwise, that's great. You can still apply it for here. It's going to be the exact same thing. First of all, we're going to change the points AB to -AB as the chart tells us to. I'm only going to tell you one of these letters, as you can still follow along in the pattern. A is going to be A located at 2, -1 is going to become A prime, which is located at -2, 1. And as I said earlier, I'm going to move on for the sake of time. And then you're going to reflect across the y-axis. Change the points AB to -A, -B. This is going to take A prime, -2, 1, and create a new point, A double prime, located at 2, 1. This is the hard question, and I had a tricky time figuring this out. I apologize, this text is very small. I'm going to try to read it out for you. Translate the shown figure 3 units to the right and down 2 units, which these multiple little boxes with various coordinates, just follow along in the pattern. 1, 2, 3, and then the arrow down is 3. The little numbers above them, if you look closely, the one with nothing above it is the very first object we have. That was the very original image. And then we have 1 over the next set, that's the prime, if you want to think of it that way. It's the first triangle in this case, is the rectangle. The first rectangle we drew in addition to doing something, as a result of doing something to the very first rectangle. And then so on. You'll repeat 2 more times. First of all, we're going to translate the shown figure, which has a little X in it if you look closely on the schematic. We're going to translate the shown figure 3 units to the right and down 2 units. So again, I'm going to just show you one example. 3 units to the right, it's going to A located at 1, 1 is going to become A prime located at 4, -1 because we moved it to the right 3 and down 2. And from there, I'm just going to keep using A for the sake of time. A prime is going to go under this new transformation, reflect the new figure over y equals x. So that's the line shown in highlighter, if you look closely. And all you have to do for again, these are all coming from the chart that Miss K gave us in the packet. All you have to do when reflecting an image across y equals x is you have to swap the values. So xy becomes yx, as we were talking about earlier. So all I did for the third is just flip everything. So if you notice, 4 negative 1 becomes negative 1 4, and so on. And then from there, we're going to rotate the image 180 degrees clockwise. As explained earlier, 180 degrees clockwise and 180 degrees counterclockwise is the exact same thing. So use whichever one you've already used or are familiar with. It's the same exact problem. And from A double prime, which is located at negative 1, 4, we're going to rotate it 180 degrees counterclockwise. And for 180 degrees counterclockwise or clockwise rotation, we're going to take AB, XY, and we're going to negate both of them. So negative 1, 4, A double prime, becomes A triple prime, which is located at 1, negative 4. So hopefully this all helped you study for this EOC, and hopefully I didn't stumble too much, and hopefully you gained something from this. I appreciate it.